So we're looking now at what is the standard deviation. And so the standard deviation is a measure of how spread out the data is from the mean or from the centre. So our range looks at from the biggest to the smallest. The interquartile range looks at the spread between the upper and lower quartiles. The standard deviation is much more about the spread from the centre. How spread out is the data from that centre point? So for example, okay, if I've got these data points here, these blue dots, they're my data points. If I take the mean in the middle, the standard deviation is looking at how spread out, how much space is there from the centre to each of the data points. And this has got quite a small standard deviation because the data points are all packed very, very closely together around that centre. If I compare that to this large standard deviation, okay, the mean is probably the same location as this example, but in this one here, the data value is not packed so closely in the centre. There's a lot more gap to each of the data values, okay, so there's quite a big jump between them. And it's that space between the values that is what the standard deviation is measuring. So it's measuring out how much distance there is between the data values. And because the data on the right hand side there is more spread out, that's going to have a bigger standard deviation. But it's always taking that distance from the mean or from the centre. So here's a couple more graphs just to give you some examples to help understand this concept. If I take this data set here and I've got a whole pile of dots, you can see there's all my data. It's approximately a normal distribution. And so we've got this black line in the middle there, which that's your mean, okay, that's where your peak is. So that tells us I've got lots of data that's all closely packed around that mean. And that's what the standard deviation is measuring, is how closely packed are these data values in the centre. Here's another example using the normal distribution graphs. You can see the red distance here, it's got quite from that centre, it's only a small distance out, okay, plus or minus 1 standard deviation. When I'm talking about the second one on the right hand side here, there's your mean in the middle, but there's a much bigger gap out to the next lot of data. So this has got a much larger spread, a much larger standard deviation. So here's 3 specific examples. So the blue curve is showing a standard deviation of 1, the brown curve is showing a standard deviation of 2, and the orange curve is showing a standard deviation of 0.5. And we can see there that our standard deviation of 0.5 here is a much taller graph because there's a lot more data closely packed to that centre. So that's why it's got a smaller standard deviation. Whereas the blue curve is less precise, there's a little more spread of the data there, and it's not quite so high. So this has got a bigger standard deviation because the area in the middle there is wider. And our brown curve, standard deviation of 2, is again much lower and much more wider again, so less precise. So there's some more information there, and I've got that website linked to you on the stats page for you to find out more. So the key ideas behind this is that we have 3 measures of spread. Just like we had 3 measures of centre, mean, median, mode, we've got 3 measures of spread, which are our range, our interquartile range, and now our standard deviation. As we progress, so when we started at primary school, we learned about the range. As we got to year 11, we learned about IQR, and now up to year 13, we're learning about standard deviation. So as we move from the range through to the standard deviation, our accuracy of that statistic is increasing. So a standard deviation is a much more accurate measure of spread than the ranges. But also, as we progress down, each of those components become more difficult to calculate and more difficult to interpret. So the range is the easiest one to calculate, you just need to know the biggest and smallest. So that's the easiest to calculate, easiest to interpret. The interquartile range, you've got to first of all find the median and then find your upper and lower quartiles, so it's a little more difficult to calculate than the range. Standard deviation, now I'm not going to show you the formula for that. There is a very complicated formula with lots of square roots and all sorts of stuff in it. And the key thing that you need to know is that your calculators and the computers will calculate that for us. We just need to understand what it is. And the standard deviation is the more complicated one to calculate, vastly more complicated, but it is more accurate if it's the appropriate one to use. And that leads us to this discussion here, is which measure should we use. So we want to use the standard deviation if our data is normally distributed and the mean and the median are approximately the same. So that means that if our data is not normally distributed and our mean and median are not approximately the same, we should not use the standard deviation as a measure of spread. Just like when we compare measures of centre and we say our mean and our median, remember the mean, if it's skewed, the mean gets pulled towards the longer tail. So in those cases when you've got skewed distributions, we do not want to use the mean, we want to use the median. The median is the more stable measure. So we should not use our standard deviation when we have skewed data, okay? But if we've got normally distributed data, then the mean and the standard deviation are the most accurate statistics that we could use.